Today we look at correlation and linear regression. So in our packet we have this page that first talks about a scatter plot. A scatter plot is a graph of a set of data points, x and y. If y tends to increase as x increases, then that data has a positive correlation. All right, so let's take a look at what that looks like. So again, as x increases, and then y increases. So as y increases and x increases, the data has a positive correlation. So let's take a look at that graph. So in class we talk about some examples of things that have a positive correlation. So it could be your height over time. So let's say we had time here and we had height here. We can see that over time, as time goes on, height goes up, at least to a certain point. So that is a positive correlation. If you got a job and you were saving your money, then you could say that over time, the amount of money that you saved would go up over time, again, if you were saving your money. So again, a positive correlation is as x increases, y increases. And a correlation means that they're related. All right, it has a negative correlation if as x increases, y decreases. So this line you can see is going down. So negative correlation might be like, let's say you have money and you spend it over time. So x could be time. And if you like to spend money over time, then the more time that goes by, the more money that you spend. You could say like, let's say you started exercising and you started losing some weight. So we could say time and the amount you exercise, or the amount of weight, it'd be your weight over time. To a certain point you'd lose weight and then you would start gaining weight for the muscle, but we could say that your weight could go down over time. So again, negative correlation means they're related, but as x increases, y decreases. And sometimes there's no correlation. So in class we talked about things that were not related at all, so we said something like your height and maybe the type of music that you like, although that could be categorized by numbers, but something like that, height and type of music, would not be correlated. And so a graph, if you were to graph that, it would be scattered, and you would see that there's no positive or negative correlation. Okay, so again, positive correlation as x increases, y increases. Negative correlation as x increases, y decreases. No correlation, there's no pattern there. Okay, so for the example, describe the correlation between each scatter plot. So this is cell phone subscribers and cell service regions from 1995 to 2003. And we would say that that has a very strong positive correlation as the subscribers increase, so do the cell service regions. Strong positive correlation. And I say it's a strong positive correlation because they are mostly on your line. Most of your data points are on your line. All right, if we look at this phone, cell phone subscribers and corded phones, so most people don't have a corded phone in their house anymore, some do, but we say that that is a strong negative correlation. Again, it's a strong correlation because they're mainly on the line, but it's a strong negative correlation, and that just means as x increases, y decreases. All right, so strong negative correlation. Okay, so to describe how strong the relationship is, they came up with this thing called correlation coefficient. So a correlation coefficient, which we call R, is a number from -1 to 1, and it measures how well a line fits a set of data points. If R is near 1 or -1, the points lie really close to a positive slope. So if it's +1, positive slope. If R is -1, the points lie close to a line with a negative slope. If R is near 0, the points do not lie close to any line. And you can see it's a continuum, so it doesn't have to be -1, 0, 1. It can be any number in between. So we could say 0.5. It could be like -0.3. It could be -0.9. It's a continuum. The closer it is to 1 or -1, the more points are on the line. So let's take a look at an example. Tell whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. So I would say that the first one is negative, but it's not 1 because they're not on the line. So I would say -0.5. For B, I would say that's 0. There's not really any relationship there. And for C, I would say 1 because most of those dots are very close to the line. So again, these are correlation coefficients, your R value, we call it. And you'll be asked about that on your assignment. Next, we look at linear regression. Regression is a method a calculator uses to find the line of best fit. If the correlation coefficient for a set of data is near 1 or negative 1, the regression equation is a very good fit for the data. So again, if it's near 1 or negative 1, a very good fit. And again, what is regression? It's the calculator finding your line of best fit. So in class, we do one example, and then you practice one on your own. So the example is this. Is there a relationship between the fat grams in food and the total calories? And we know that in a table, the independent variable comes first. So total fat is X, the amount of fat. We want to know, is there a relationship between fat and calories in a food? As one goes up, what happens to the other? So we're going to graph this. And again, all the instructions that I go over, I'm just following all of these steps right here. So it says enter the data into a listen spreadsheet. Call X fat, call Y calories. Okay, so let's do that. So you go home, new document, don't save unsaved, add a list and spreadsheet. I'm going to call my first column fat, I'll call my second one for calories, and I'm going to enter in the data. So I'm just entering in the numbers that are in the table that we just looked at. Okay, so there's 11 pieces of data, and I'll enter in the calories. That should have been 560, sorry. Okay, so we've entered in data, and now we're going to find a line of best fit. So to do that, we're going to go to Menu, Statistics, Stat Calculations. Oops, went too fast. So Menu, Statistics, Stat Calculations, and we're going to do the first one. So it went really quickly, but it's linear regression, mx plus b. So arrow over and select for x was fat, and then y values was calories. So again, the buttons were Menu 413 is how we got there. All right, and then if we go over, we have a bunch of information. I have to go up to find all this right here. So we have, here's the equation, mx plus b. It gives us the slope. The slope is 11.7, positive slope. The b value is 193.8, and that's the y-intercept, 0.85. And our r value is 0.97. So let's write that down. Oops. Okay, so right here, the slope is b. And here the slope was 11.7. Oh, or sorry, the slope is not b. Okay, let's read that up. The slope is m. M is the slope. And here our slope was 11.7. The y-intercept is b. And our y-intercept, and I forgot already, so let me go back. Our y-intercept was 193.9 all round, 193.9. Here. So slope was 11.7. This is 193.9. So our equation for the line of best fit, remember, it's y equals mx plus b, so 11.7x plus 193.9. So we start at 193.9 calories, and we add 11.7 grams of fat for every, or 11.7 calories for every fat gram. So here's your equation of line of best fit. So in class, we've been doing this by hand, calculating slope, calculating y-intercept. But now your calculator does it for you. There's the slope is 11.7, and the y-intercept is 193.9. All right, there was an r value, and our value was 0.9746. Let's write that down. R value 0.9746. And that tells us it's a positive correlation, and not only that, it's a strong positive correlation. Because that number is close to 1, I'll put strong positive correlation. And again, the closer the numbers to 1, the closer the lines are, or the points, the data points are to your line. All right, so let's see what that looks like. What does that look like? And so it says to make a scatter plot, and again, I'm just following in on the notes here. To make a scatter plot, press Control Dock, open a new page, select Data and Statistics. Hover over x-axis, select fat. Hover over the y, select calories. All right, so let's do that. Let's see what the scatter plot looks like. So in an empty cell, I will hit Control Dock, add a new Data and Statistics. Down here, we're going to click and do fat. Over here, we'll select calories. And we can see that, yes, this is a strong positive correlation. To find the line of best fit, we can go to Menu, Analyze, Regression, and show the linear. There's two of them. One has the slope first, one has the y-intercept first. So let's put the slope first. And again, there's that equation that we came up with our slope and our y-intercept. And then you could use that to make a prediction. Like if I gave you any number of fat calories, I could plug in for x, and then we could figure out how many calories that food would have. So again, positive correlation. As fat increases, calories increase. So in class, then, you're going to be doing the same thing. So our assignment will be to finish the packet where it talks about correlation coefficient, how good is your line of best fit, and then it will actually have to calculate a line of best fit on the calculator.